In this module, we're going to look at meshes, not fabric, but wire woven meshes and perforated meshes or perforated panels that allow us a sense of transparency or translucency as in many applications a second level of the facade, a double facade kind of concept. So in order to get started with that, I have a case study that we can quickly review. It's the Fulton Center. It's a transportation hub in downtown Manhattan. I think a lot of investment went into this because of 9/11, and it's an innovative use of a panel that is perforated to create an oculus. So we see this kind of the structure. It has an exterior and an interior. You'll notice that it's really we're outside of the building on the other side of this structural element. That'll be important when we look on the inside of the building. So here it is at grade. So here's the oculus coming way up with a cladding on it. And we're going to concern ourselves with what's going on inside. This is a subway intermodal transportation hub. And here's a look at the oculus from the concourse at grade, looking up, and quite a beautiful, complex-looking shape. And here's what would be a mock-up probably to describe some of the details of how the panels would look. Some of the idea of how they were all different shaped. You can see the double cable system. This is going to be a tensioned cable system in order to suspend it, and the concepts for the attachment systems. And here we have it just to give you an idea of it being erected and the panels being put in place. I caught this while I was researching this. This image was important to me because it told me that it was likely that a lot of the design work that happened with this project was done inside of the rhino grasshopper environment, indicated by this red in the X, and is very typical for the loci descriptions inside of Revit. The green typically for the highlighted elements. So this is tells me that it was probably conceived within that programming environment. This shows you that oculus suspended within the building, and the associated structures that go with that. And here it is. Here we can see the outside cladding panels, the superstructure to support the glazed roof system, and then the support of the cable tension system in the actual oculus itself. We'll take a few minutes and look at this video because it's very descriptive of its installation. And I think it's important for us as architects to think about how we need to describe some of the larger aspects of the things we want to accomplish in our architecture, how we need to explain that to a lot of the players. This was done by Enclose. It would be very likely that you could be an architect working for Enclose or working within the team of people, and a lot of discussions were going on, and it was determined in order to get everybody on board with the feasibility of doing this project, we needed to have a really descriptive way of telling what was going to go on. So this goes to the heart of how do we get this cable net in here, accessibility to the building while it's under construction. You can still see the drywall even looks like it's still got tape joints on it. And this is the real world view of that, just to show you the similarities from what they modeled to what they actually built. So what they're doing, this is the cable system. It was wrapped around that spindle to keep from kinking it too tight. Now they're opening it up to lay it out flat. And probably getting ready to put the rigging down for the rings. This is the tension ring that's going to hold the cable net up into the oculus. And an idea of how many team members would be needed to manipulate and erect it, and obviously another image of that looking very similar. So this is hung by a crane right now, and the cable net being attached to it. So here's a larger expanse of that being put together, and then the individual attachments to that ring of the cables. And a little time lapse of that happening. I think they had an elevator over here they needed to protect, and they needed to know that they could set that ring up and not have it interfere. This is a great image of just the sophistication of our animation graphics, even at this level. to show the physics of a mesh system, moving back and forth as it's pulled up into space. So this would be a real confidence builder in the idea of explaining things to the contractors and the fabricators that would be involved in this. This is showing the setups once the cable is in place of opening those clip systems up from the way they were shipped, and then starting to attach the panels. And we have a jib hoist down there, and we have some scaffolding, like window washing cable hung scaffolding systems, indicating how many people could be erecting, the need to deal with the shape of the oculus with the scaffolding system, and some details of it being erected. And so there was a lot of, I think, information delivered in a relatively short video. So let's go back to our presentation. And in here, I'll go through a few slides that are a bit sharper than the videos or the other things that I've shown you. You can see the really beautiful cable system, the beautiful stainless steel hardware and cable systems. All has a really beautiful appearance at the at a level, and a lot of this attachment here is visible from the glazing of this second or third level mezzanine area. Note the cable systems coming down here. I zoomed in on one of these images. And then the need for this structure in order to pull this into tension. So there's probably a lot of steel beyond this to support these outriggers, because there's a lot of tension within these cable systems. So obviously we've done things with our parking garage assembly where we've looked at this like second layer of facade, and this is just another example of that. Looks like a museum. I don't know if I have this one hyperlinked. Yes, I do, so you can go and visit it for more detail. But a perforated panel, this could be likely an aluminum panel with a laser cut opening. In this case, the laser cutting only opened up some holes and left other holes with just the blank still attached, so that it could be deflected to create that kind of second layer of appearance. And our fabric systems, in this case, I believe this could be a metal mesh that's painted, but here we're twisting those meshes in order to create a piece of visual interest in the facade. A lot of these are around parking garages. So here's another example. We're no longer looking at a metal mesh now, but we're probably looking at a fabric system in order to create these sail-like structures. These are structures that are in tension, like a sailboat would have in order to catch the wind and stay rigid. This is on the medical campus in Buffalo, New York. And just a couple of views. I think this is an attractive one. I think one of the problems with this installation that kind of troubles me is the right across the street kind of look at the facade, where you're seeing a lot of the exposed concrete of the parking deck. But there are many places where this is really quite beautiful or quite attractive. And then right across the street, this is just really kind of a diversion, but important enough. A couple of things that are happening on the medical campus that should be interesting to us as architects. We're going to deal with glass. And so this is a great example of a fritted glass designed specifically for the effect of kind of keeping with this concept of these rolling surfaces. So they've fritted this in a dissolving pattern, gives the appearance that might be coming into like a continuation of this curved surface. But these are now windows instead of solid panels. One of the downsides of this installation happens to be these shades that are drawn, and all of the variation from who had shades at different levels. This is very typical of us envisioning a beautiful dark surface and then it being by users, having attachments of other things to it. So along that, so we moved down the street here, and I just wanted to point out this really streetscape intervention. The parking on the campus, the ability to keep it a high-end, beautiful place, and then kind of hide the cars, pull them away from from the walking space. They made a very generous sidewalk and then landscaped it in a really delightful way. So you really aren't even aware that there's cars parked over here, even a buffer from the street parking. Here we have, at the pedestrian scale. I was kind of thinking this is great, somebody out enjoying this green, fresh air, and then they lit up a cigarette. But nonetheless, this is I think, a really great example of a streetscape. For those of you that are in class in real time, we have a quiz. And then we'll move on to kind of the specifics of this idea of meshes, because there's a wealth of different sources and types of styles. So basically we have the idea of woven wires, stainless steel typically, woven on a machine, where these are woven just like fabric, of huge variety of choices here. Expanded metal, the best example of expanded metal might be industrial staircases, where you have metal that's been with a grating on it in order to create a slip resistant surface. In this case, you slit the metal with a die, and then you can pull the metal out, expand out the sheet in order to open up these openings. So this is an industrial material. Typically, you don't find it in stainless. So there's issues of corrosion. Many times you'll buy this in a galvanized form. But there are issues with this as far as long-term appearances. We have perforated metal also then. So this is another way to open up metal in order to create kind of translucency. Lots of choices in our metal gauge, the thickness, the amount of opening area, and the material that it is punched out of. So over here we have, this is probably more at the Fulton Center kind of mesh material. Important, kind of maybe a little familiar with the manufacturers or the players in this. GDK, a European manufacturer, very high-end metal woven fabrics. McNichols is a stateside distributor and manufacturer, and Cambridge Architectural is also in the U.S. Not to say that these aren't available all over the world. So attachments, like we saw in the Tension Fulton Center, the connectors, the way they're terminated, all part of architectural and visual interest and a consideration for us. So this is actually a woven metal also, where we have a rod, but we have a flat stock that's interwoven with it. So once again, that really huge amount of choices. Here's a project that on its face, I guess in the daytime, I don't really find all that attractive, but I'll just shoot ahead here. At nighttime, it can become really quite spectacular looking. The nice thing about these meshes is their ability to catch that light to create that kind of a fog-like appearance around the building. Here's another close-up of it. And so we have that idea of that second layer of the facade, the glaze layer, and then the mesh or gauze that goes over it, and a couple of kind of details about what it looks like going up. Here it is prior to any panel installation, so you can see those bows. So we have a square building, a cube, in fact, but then the facade bowing out to create another second kind of shape form. The idea of light can even be carried down to a very detailed level, where we have now LEDs placed within our screen system, and we can use it as signage, create different colors with it, other kinds of effects on the facade of the building. So this manufacturer has one of the woven elements, a tube system with LEDs in it, red, green, and blue. When they're all on, you get a white color. When they're and then as they're modulated, you can produce any color you want. Just in my searchings of all of these things, I came around this really beautiful transit hub, and I thought it was noteworthy to keep it in the slideshow. So here's, I think this is Cambridge Architectural. This is a Las Vegas parking garage. So Morphosis, this is in San Francisco, a double-layered kind of building with that mesh on it. I have this hyperlinked, so it will take you to their website so you can look at some of the details of this project. and decide if it's successful or not for things that you might be interested in. So a few cautions about the use of metal mesh systems and fabric. This idea of dimpling, you can imagine anticipating putting all these tension panels up and having a beautiful flat surface, and then with some heavy side lighting, seeing what is called smiles on the panel systems. Because of the lack of support at the edges of these. And you'll notice the smile disappears where there is a rib supporting that panel. So not necessarily a deal breaker, but it would be really disappointing as a designer if you hadn't anticipated this kind of final effect. One of the other really nice features of perforated metals is this idea of transparency, obviously. So I'm going to punch up on that a little bit in the next couple of slides. This is a project, I think this is probably a hyperlinked slide to this project and some nice details of it if you want to investigate it. And here's a close-up of it. This is very similar to what we've done. I promise you I did not copy this. I stumbled upon this after I'd started the project. But this is a really much nicer, I guess, visioning of the concept where the facade is actually coming out to create an entry canopy. Here's an example of a facade with a perforated metal where the panels are planar, but there is some shifting in the shape and form in order to sculpt the building. This is a once again another kind of fabric on the exterior of the building. The metal meshes can serve, I put this in because the metal meshes can serve a multiple of functions. In this case, it can be a fall arrestor, just like a railing system on the second floor. So there was no need for any other visual interruption of a handrail or rail system across here to prevent falls. And that's a way of reducing the installed cost if you're using this in applications where you're trying to second story applications where you're concerned about people falling. So here's another example of that where these are actually used as railings, and then these infills, you can see the glass panel for the railing at this point. And I think this is a really nice nice facade. So you can form, I have really mixed feelings about some of these applications. And we have at Rigidized, when I was consulting with them, we would get customers like NBBJ, a major architectural firm, probably missioned to enhance a facade for a client, looking at some kind of a metal attachment. And so you can see there's very similarities in our project to the kind of attachment systems that would be happening in the real world. And then I've already shown you this. This is rigidized metals, the idea of creating a security system with the metal over the glass layer to prevent breakage, but also the ability of these metals to reflect light again. Once again, the idea of making these work more than just in one kind of lighting condition, use the idea of auxiliary lighting. In this case, just a traffic light down the street would reflect green or red depending on what was set. This is a parking garage again, metal mesh, originally proposed by the client. We kind of inspired them to modify it. This is really just a walkthrough of some of the issues you would deal with when you're working with the vendor and the architect, and you're the architect. The attachment systems, where we're going to add metal to the bottom, we're going to have a return on it, and then making mock-ups. So we made little panels so that we could look at how this would look as we attach the metal to the frame structure. I thought the bent one had the nicest effect, but there are issues when you bend around the corner of how the pattern changes. All in all, that seemed to have the nicest appearance to it. And then, walking through all the ways it would be attached to the building, the limits of the size of the panel. So here we have 4-foot widths, and the idea that there are going to be these seams here and how we're going to deal with those seams. A mock-up of what the facade would look like on the building. In this case, I think one of the mistakes we made is we underestimated the contrast between the concrete and the metal. Very disappointing in the final project. So here we have ideas about the way the assembly would go together for fast fabrication. And then once again, I said, and I showed you a slide too early, but this idea of transparency. So here we're looking at a mesh system. We can, looks like it's fairly opaque. We can see through it a little bit, but as you step back from it, it really has a great deal of transparency. And you can see the read of the seams of this panel. And I'll show you some of that of it getting fabricated. So here's a mock-up, all stainless steel framework in the factory, a mock-up that we were at the very beginning of the project creating for the client, dealing with the idea of how we would tack weld these to the panel without having fasteners through the front. This is obviously myself and the master fabricator. And the idea of what the seams look like in the shop, it looks really good. You can see the idea of the transparency of it. But in order to really be useful, we needed to get it out in the daylight to see what it looked like. So here's the panel mounted up on the building, and you can see a little hinting of the seams. But this is a good shot. This would be the more of the how you would see it from the road, kind of on an oblique angle, but still acceptable. And here it is going up on the building. And I thought the net effect was really quite disappointing, and I should have really kind of anticipated that, thinking about how this building actually reads also with that metal on it. But that wraps that up. I don't want to leave it on a sad note of metal, because there are many beautiful applications of metal like this building that I think are really quite outstanding.